Hey y'all, welcome back to Stats from My Home. As I set up a little bit. So tonight, today, whenever you watch this, we're going to be talking about two-way ANOVA. In the last lecture, we went over one-way ANOVA. Just to recall and refresh a little bit, one-way ANOVA is whenever you have one independent variable with three or more levels. So one of the examples we were talking about was listen to classical music, heavy metal music, or no music while you're studying. So you listen to heavy metal music while you're studying, you listen to classical music while you're studying, you listen to no music while you're studying. And then you measure your memory. And that could be a between subjects experiment in which one group of people listens to classical, one group of people listens to heavy metal, one group of people listens to no music, or within group, or within subjects experiment, in which each person is in each listening condition, classical, heavy metal, no music, and has a memory task after each study session. So it's one way ANOVA. Now, you might be thinking, kind of simple, that that experiment is not very complex, and maybe the world works a little bit differently than that. In which case, I would submit to you that you're right. Life is more, life is often more complex than one independent variable experiments would suggest. Because really, another way to think about what an independent variable is that independent variables help explain why the world is what it is. The conditions of that listening experiment, the listening while studying experiment, help explain why people learn the way that they do. If people learn better when they study without music than if they study with music, or if they study with more specifically to the experiment, if they study with classical music versus heavy metal music, that helps us to understand the world. That helps to explain something about how we learn. Specifically, that we learn best when there's no distractions. That the way in which we have people try to learn things while listening to no music, classical music, heavy metal music, will explain something and give some reason as to how our mind works and how and why we can learn the way that we do. Right? So if because life is a little bit more complex than one independent variable experiments would suggest, then what do we do? Well, the easy thing is to add more independent variables. Basically, we just build experiments that have more nuance to them. We build experiments that try to approximate better the way the world is in the lab so that what we're studying, we can do it in a more realistic kind of way. Right? We don't, so building on this idea, well, that, okay, yeah. So, yeah, the one thing is that there are multiple ways to explain how the world works. And there are multiple things that can affect an outcome. There are multiple reasons why some event happens. People learn in a certain way because of how distracted they are. People also learn because of how easy it is to learn the material. People also learn better when they're interested in what they're learning. People also learn differently whenever they have some kind of motivation to learn. They're that they're being forced to learn versus they want to learn, right? There's a lot of factors that affect how learning happens. And one factor that affects learning is the condition in which you learn. One factor that affects learning is what you're listening to while you're studying, right? And so this is just learning. This is just one measure that psychologists will use. Studying, memory, right? That's just one thing that psychologists will study to be, that people do. One behavior that people do, you know, and think of other things that psychologists study: self-esteem, emotions, why we feel certain ways, why um, depression, other clinical outcomes. Just let's just focus on happiness. What makes people happy? There are a lot of different explanations as to why people are happy. And people are happy when they get, for instance, receive gifts. People are happy when they give gifts. There's a big literature on that. People are happy whenever they see. There's a literature that seeing babies and baby animals makes people happy. I guess it's somewhat timely for this discussion, right? So what I'm trying to impress upon you is the fact that there are so many different ways. There's so that for human behaviors and cognitive processes, there are often multiple reasons why an outcome will happen. And accepting that truth will help to make sense as to the necessity, excuse me, of conducting experiments with two independent variables. And so that's what we're talking about. We're talking about building more complex experiments and analyzing more complex experiments. Specifically, complex experiments in which there are two independent variables, two-way ANOVA. That's what that means, two-way ANOVA, two independent variables. Each independent variable, just like in one-way ANOVA, is a nominal independent variable with an interval ratio dependent variable, and we're just comparing means. We're comparing condition means. Even though we're talking about ANOVA, and even though one-way ANOVA has to have 3 levels or more, two-way ANOVA, two independent variable ANOVA, can have two independent variables, each with 2 levels, right? The smallest two-way ANOVA that you can run is what's called a 2 by 2 independent. It's 2 by 2 ANOVA, in which there are two independent variables. Each independent variable has 2 levels. So, in the parlance of two-way ANOVAs, we always will talk about a blank by blank ANOVA. And those are numbers. And those numbers tell you how many levels of the independent variable there are. So if I'm talking about a 2 by 2 ANOVA, with two independent variables, because 2 by 2 means two independent variables, and each of the independent variables has 2 levels. So um, we'll we'll build an example. Um, in a little bit to make that completely clear. There's a few examples we'll talk about um, in this lesson. But imagine we have a 2 by 3 ANOVA. That means we have, again, 2 by 3, two independent variables. One independent variable has 2 levels. One independent variable has 3 levels, right? Pretty simple stuff. And what's different for two-way ANOVAs is that, well, one thing that's different between two-way ANOVAs is that we're no longer really interested. We move past just group means, and instead we're interested in the combination of the groups, which will become a little bit more important. So let's take a simplified example. Let's take a version of the experiment we talked about in the one-way ANOVA lecture, in which one finding that I'll submit to you from cognitive psychology is that it's easier to remember. It's easier to you will remember better when you study while not distracted than if you study while you are distracted. So it's easier to study. It's better to study. You'll remember more when you study with no music than if you study with any music. So we might simplify the one-way ANOVA experiment we did to go from studying with no music, classical music, or heavy metal to just study with no music or some music. Now we're talking about two groups, right? We're in t-test territory. It becomes a two-way ANOVA whenever we put another independent variable on top of that. So studying while listening to music, studying while not listening to music, and the second independent variable would be what we're studying. I might be asking you to remember words, or I might be asking you to study words, or I might be asking you to study pictures, right? Two common tasks in cognitive psychology. So remember this list of words versus look at this list of pictures and tell me which ones you've seen before. So now there's two independent variables. What we listen to, what we listen to, which has 2 levels, listening listening to music, no, not listening to music, and what we're studying, words, pictures. So now with this 2IV experiment, what's really important is the combination of these levels. So what we really care about is how do people how well do people remember pictures while listening to music, or pictures while not listening to music, versus words while listening to music, or words while not listening to music. The main thing we care about, the main focus of two-way ANOVA is the combination of the conditions of the independent variable. Whenever we take whenever yeah we can graph out the levels of the independent variable to look like a like a matrix, like a chart, to have rows and columns, and where the rows and the columns combine, the combination of those factors is really what we most care about, the two-way ANOVA. So in this example, it'd be a 2 by 2 ANOVA because listening condition has 2 factors: no music, music. Sorry, didn't mean to flip you all off. Versus the the stimulus independent variable is either is either words or pictures, right? 2 by 2. No music, music, pictures, words. 2 by 2. And just like in one-way ANOVA, the the specific type of two-way ANOVA um, can come in a few different flavors: between subject, within subject, or a new one, mixed. We'll talk about what each one of these are. We already know, we can already probably think about what a between subject two-way ANOVA would be. So for one-way ANOVA, or for that instance, t-tests, a between subject experiment is when different group of people are in each condition of the IV. There's a group of people who don't listen to music. There's a group of people who do listen to music, completely separate people. Versus a within subject experiment would be the same group of people studies while listening to music, and then a group of people studies while listening to music, and then that same group of people studies while not listening to music. Within subject. For two-way ANOVA, the same logic applies, but just a little bit more complicated, because the focus goes from just the conditions themselves to the combination of conditions, the cells of the design. If we were to make a little table out of this, and we'll be more explicit with what the cells means in a little bit. But basically, a between subjects ANOVA, a fully between subjects ANOVA, would be when a separate group of people experiences I got distracted. When a separate, okay, coming back, focusing again. A fully between subjects ANOVA is whenever each combination of the levels of both independent variables is a separate group of people. So in the listening to music studying while listening to music, studying pictures while listening to music, that's one level of stimulus and one level of listening condition. So one group of people will study while listening to music, will study pictures while listening to music. A completely separate group of people will study words while listening to music. A third group of people will study pictures while not listening to music. And a fourth group of people will study words while not listening to music. Each combination of the levels of the independent variable is a completely separate group of people and that's fully between. Versus fully within, a within subjects design is each person each person experiences each combination of the levels of the independent variable. So there's a single group of people, and the group of people first studies words while listening to music, and then studies pictures while listening to music, and then studies words while not listening to music, and then studies pictures while not listening to music. Each combination of the independent variable in the same group of people in each combination. Now, that's fully between, fully within. And the new flavor of ANOVA, new flavor of design that we're going to talk about, it's the last kind of design. Yeah, I'm not going to say that. So a new kind of design we're going to talk about is a mixed design in which one independent variable is between subject and one independent variable is within subject. It mixes between between, and within. And so an example of that might be that people are only in one listening condition. Each person is randomly assigned to either be in the list studying while listening to music or studying while not listening to music. And then they'll study words and they'll study pictures. So some people, one group of people is going to be randomly assigned to study while listening to music, and they're going to study some words and recall those words, and then they're going to study pictures and then recall those pictures, and then a separate group of people is going to be assigned to the no listening condition, in which they'll study words and recall, and then study pictures and then recall. Right? So that's a mixed design. One independent variable is between, and the second independent variable is within. And why you would use this kind of design is a question that's beyond beyond this class. You'll talk about that in methods. But you can kind of imagine. Yeah, we'll just kind of leave it there. It's just the case that some types of experiments are better for mixed designs than being fully between or fully within. All right. So those are the flavors, the different kinds of two-way ANOVAs. And so I'm going to share my screen just for a second. I'm going to share my screen just to kind of be just to re-emphasize why. So this is another look of a more complicated design, right? So this is the original experiment that we talked about in the one-way ANOVA lecture. Classical music, studying while listening to classical music, studying while listening to heavy metal music, studying while listening to no music, and trying to remember words versus trying to remember abstract pictures. This would be a 2 rows by 3 design. If each person were randomly assigned to one and only one combination of these independent variables, one and only one cell. So this is in this table where the rows and the columns intersect is a cell. So this is a cell. So this cell is a combination of studying words while listening to classical music. This cell is a combination of studying abstract pictures while listening to classical music, so on and so forth. And again, the benefit of let's kind of return to now the benefit of using two independent variables, because it might be the case that the condition in which people study matters. It might be the case that what people listen to while they study will affect their memory. It might be the case that what people study will affect their memory. So just imagine a different condition of this. Imagine I was having you study words versus high-level statistical concepts. You would probably perform differently in these conditions, because it might be easier to remember a list of words like apple, orange, grape, banana, strawberry than it would be to remember um, what variance means, what standard deviation means, what ANOVA means, right? So the different stimuli might be easier or harder to remember. And different conditions in which people learn might be more or less conducive to learning. Both of those things might be true, but it might also be true that the way in which those conditions combine, the way in which the environment and the stimuli combine might be even more interesting and important than either of these two independent variables by themselves. That's kind of a hard it, that's kind of a hard thing to wrap your head around, but let's build up to it. I just one more time, you might have heard this kind of language before, that the the combination of the conditions is more important than the sum of their parts, right? We have the what being in a an ideal environment, trying to study the easiest kinds of things might be the absolute best way to study versus being in the worst environment to study while trying to remember very difficult things might be the might be even more difficult than just than combining these two things by themselves. So the combination of two levels might be can sometimes be more um, can produce a different effect than just listening to heavy metal versus trying to remember words versus pictures. And we'll be a little more concrete about this in a minute, because really what we're talking about is what two-way ANOVA does for us, what two-way ANOVA gives us. There are three effects, three components of a two-way ANOVA. The first we'll talk about is main effects. Main effects are what we talked about in one-way ANOVA. So just imagine for a second that we were only interested in classical music versus heavy metal music versus no music. That is a main effect. That a main effect would be irrespective of what people studied, how did the environment affect learning? The main effect of stimulus would be just words versus abstract pictures, irrespective of the condition in which people learned. How well did people remember different kinds of stimuli? These are main effects. So really what we end up doing is we just average over words and pictures to get an overall average of classical, of how well people studied while listening to classical music, an overall average of how well people studied while listening to heavy metal music, and an overall average of how people studied while listening to, excuse me, no music. And we compare these overall averages and overall combining over words and pictures in each of these conditions to create overall averages. And that's a main effect of learning environment, main effect of listening condition. We average over stimulus to get these averages. Versus here, we average over we average over people who study. I'm pointing at the screen. People who studied while listening to classical music, studied words while listening to classical music, studied words while listening to heavy metal music, and studied words while listening to no music to get an overall average of words. Same deal for pictures. We average over, we collapse over how well when people studied classical studied pictures while listening to classical music, studied pictures while listening to heavy metal music, and studied pictures while listening to no music to get an overall average of pictures. And so that's a main effect of stimulus, of what people studied. So there's two main effects. One in which we compare the overall averages of the learning environment, the listening conditions, and the overall environment of the stimulus. Those are two main effects. And for all intents, this is just the same as a one-way ANOVA, and this is just the same as a t-test, right? So we have a one-way ANOVA and a t-test. That conceptually, and yeah, and mathematically in a lot of ways, explains what main effects are. And if that were all two-way ANOVA did for us, we'd be done. But then we have interactions. And interactions are what make two-way ANOVA incredibly useful. Because for the most part, the interactions are what's interesting. When there is an interaction, that is what researchers care about. Because the interaction means that something more complex is going on. It's not just the learning environment. It's not just what people study. It's the combination of the learning environment and what they study, the combination of one independent variable and another independent variable. And the definition of interaction, which you're just going to really have to commit to memory, because it's kind of hard. It's kind of hard to interactions a kind of difficult concept, and you're really gonna have to work hard to get this definition into mind. But the definition of interaction is when the effect of one independent variable changes at the levels of a second independent variable. Once again, the effect of an independent variable changes at the levels of a second independent variable. Now, it's kind of a hard concept to wrap your head around, but let's just think about how things in life interact. Let's pretend we're physicists for just a hot second, and I'm going to exhaust pretty much everything I know about physics right here. And it's very intuitive physics, so don't get lost. Don't check out. Think about what you know about liquids. Think about what you know about solids. Imagine, hold on one second. Okay, this is a glass. It's an empty glass. It's filled with nothing but air. Imagine you you dropped a strawberry into this glass. What would happen? Not a very profound question. The strawberry is going to drop to the bottom of the glass. Air is not conducive to supporting a solid by itself. Now, this is a glass of milk. We could call it heavy cream. Let's just say it's a glass of heavy cream. What happens if you drop a strawberry into this into this liquid? Well, if you drop a strawberry into a glass of milk, it's probably going to sink to the bottom, because most liquids by themselves that we encounter on a daily basis, water, for instance, is not going to support a heavy solid like that. a solid that's more dense than liquid is. But imagine we take the heavy cream and infuse it with air. We create whipped cream. Whipped cream is cream that has a whole bunch of air bubbles in it. You take heavy cream and you put it in a bowl and you get a whisk and you whisk until your arm feels like it's going to fall off, and then you have whipped cream. And what whipped cream is, it's a liquid with a whole bunch of little tiny air bubbles trapped inside. And if you take a strawberry and you put it on top of whipped cream, it will sit there. And why are we talking about this? Because the properties of air by itself and the properties of liquid by itself each have the same effect. The effect is, when you drop a solid into air, it sinks to the bottom of the vessel. When you drop a solid into liquid, it drops to the bottom of the vessel. But the combination of whipping air into some kinds of liquids will interact and create a substance that is different from either that the effect is different than either of the two elements by themselves. So the way that when air gets trapped inside of some liquids, it creates a very different outcome. And that's an interaction. Here, the air and the cream interact by creating a solid on which another solid, a strawberry, can sit on top of it. So that's an example of an interaction happening in kind of a physical sense. But let's talk about an interaction that's a little bit more psychologically relevant. Specifically, let's think about how much let's think about food. Let's think about food toppings specifically. I might ask you, how much do you enjoy eating hot dogs? Versus, I might ask you, how much do you enjoy eating ice cream? Right? You know, in the parlance of traditional psychology, we might ask for, what is your preference for this versus your preference for that, or rate how much you like hot dogs on a scale from 1 to 7, or rate how much you like ice cream on a scale. So that'd be a main effect. How much do you like this versus how much do you like that? How much do you like hot dogs versus how much do you like ice cream? Now, I might ask you, how much do you enjoy putting ketchup on food versus putting chocolate on food? Or I should say hot fudge. So I can ask you, how much do you like putting ketchup, using ketchup as a condiment? Rate versus hot fudge as a condiment. Rate how much you like ketchup on a scale from 1 to 7. Rate how much you like hot fudge on a scale from 1 to 7. Now, you might already be imagining where this is going, because when this independent variable interacts with this independent variable, how much you like hot fudge depends on the level of this independent variable, such that you really like hot fudge when it's on ice cream, but hot fudge on a hot dog is gross. Versus you might really enjoy ketchup on a hot dog, but ketchup on ice cream is disgusting. The how much you like hot fudge, the effect of liking, so rather how much you like hot fudge relative to ketchup. That's what's important to focus in on here. Hot fudge relative to ketchup. Here we like hot fudge much less than we like ketchup. When we put hot fudge on a hot dog, we like hot fudge a lot less than we like ketchup. Here, the effect of hot fudge is much greater than ketchup. The comparison, if we just think about if we just think about simple mean differences, that here we're at a 10, and down here we're at a 0.5. Down here we're at 0. So if we subtract ketchup minus hot fudge for hot dogs, we get 10 minus 0, which is positive 10. Over here, if we subtract ketchup minus hot fudge, we get 0 minus 10, which is negative 10. So the effect of comparing hot fudge to ketchup differs at the levels of the other independent variable. To think about it another way, let's go back to the notes and put some real means into this design we've been talking about. So we have listening conditions across the top, learning environment, I've been calling it either one. And we have across the rows and across we have listening conditions across the columns and stimulus across the rows. Now, there is a theory in cognitive psychology that if we have two things that use language occurring at the same time, there's going to be interference. So if I'm listening to words, I'm processing those words. If I'm studying words, I'm processing those words. Processing two words at the same time doesn't work. Versus processing words and processing pictures are two separate things, and they won't interfere with each other. And here, classical music has no words, and I'm kind of getting ahead of myself. That's kind of the theory in which we're working. And so let's just look at these means. Let's look first at the main effects. Here we see a main effect of learning environment, sorry, where people remember best when they study while not listening to music. They remember worst when they study listening to heavy metal music, and they're kind of middle of the road when they study while listening to classical. Versus people are about equally good at
remembering words versus remembering pictures. There's a slight advantage. There's a mathematical difference where it's easier to remember. It's mathematically easier to remember words than pictures, but it's unclear whether or not there's a significant difference there. So these are the main effects. 14 versus 13 is the main effect of stimulus. 23 versus 6.5 versus 10.5 is the main effect of learning environment. But let's dig into these combination of conditions because that tells a different story. Something more complex is happening. So here, and we can get this, we can view this a little bit more clearly if we compute what's called a simple effect. Because let's remind ourselves again the definition of interaction. The effect of one independent variable changes at the levels of the second independent variable. The effect comparing words to pictures changes at the level. This is level one of the second independent variable. This is level one of the second independent variable. The effect comparing level one, level two of the first independent variable changes at the second level of the second independent variable, and it changes again at the third level of the second independent variable. And so we can compute simple effects by looking at the effect here, looking at the effect there, and looking at the effect there. So the simplest way to do this is just think about, I'm trying to cover it, is to just think about this as one t-test. This as a second t-test. And this as a third t-test. So thinking about just looking at words versus pictures for classical music, just looking at words versus pictures for heavy metal music, and just looking at words versus pictures for no music. Those are three simple effects. The effects of stimulus at each level of the independent variable, of the other independent variable. And just to make this crystal clear, I'm going to actually remove this. I'm going to remove the main effect of words versus pictures. And so what I've done here is I've calculated simple effects, which basically what I've done is I've calculated the numerator for t-tests. I've taken the mean of words, the mean of studying words while listening to classical music, and subtracted the mean of studying pictures while listening to classical music. And I see that 14 minus 7 equals 7. Here, I've taken the mean of studying words while listening to heavy metal music and subtracted the mean of studying pictures while listening to heavy metal music and see a simple effect of -7. 3 minus 10 is -7. And then, as you might expect, I've taken the mean of studying words while listening to no music and the mean of studying pictures while listening to no music and subtracted that. So 25 minus 22 is 3. Now notice something. Well, first, sorry, getting ahead of myself. Notice something. This number's positive. This number's negative. This number's positive. That means for this condition and for the class studying while listening to classical music and studying while listening to no music, people remembered more when they studied words. And when when people studied while listening to heavy metal music, they remembered more when they studied pictures. So the effect of what people studied changed depending on the condition in which they studied. The effect here for classical, this simple effect is positive, this simple effect is positive, this simple effect is negative. The effect was different at the level, the effect of stimulus was different at the levels of the second independent variable, learning environment. So what people were trying to remember, the effect of trying to remember words depended on the condition in which they were learning. It's easier to remember words when studying when studying while listening to classical music and studying while listening to no music. It's easier to remember pictures when listening to heavy metal music. Another thing to look at here is the fact that 14, 3, 10, 7 versus 25 and 22. People's memory was a lot higher, excuse me, was a lot higher just kidding. Sorry. I'm not gonna go down that road. But just once again, point out here, this is an interaction because the simple effect, just taking a very simple difference, because that's the building blocks of a t-test. That's the building blocks of an effect changed at the levels of the second independent variable. And just here are some interpretations that we can make from this block of means. That it's easy when you study words, your memory is when you study while listening to classical music, it's easier to remember words. When you study while listening to heavy metal music, it's easier to study pictures. Your memory is a lot higher for when you study while listening to no music, and there's a slight advantage for studying words. And basically, that's pretty much all I want. I mean, beyond these hypotheses, that's what's different. That's what's new and what's interesting. That's why we do two-way ANOVAs. In the lab, we're only going to focus on calculating two-way independent ANOVAs, but two main effects in an interaction are present for all two-way ANOVAs. So just kind of, I want you to understand conceptually that there are 3 different flavors of two-way ANOVA, like we talked about earlier: fully between, fully within, and mixed. And that every two-way ANOVA, whether it's fully between, in which each person, each combination of the levels of the independent variables are separate groups of people, versus fully within, which is each combination, each combination of the levels of the independent variables are the same group of people, versus mixed, which is whenever one IV is between, one IV is within. For all three flavors of two-way ANOVAs, there are 3 hypotheses because there are 3 components: a hypothesis for main effect, hypothesis for the second main effect, and a hypothesis for the interaction. And just like within every single hypothesis test we've been talking about this semester, there's a null and the alternative. And just like within every null hypothesis, the null hypothesis is that there's no effect. There's nothing going on. There's no change. There's no difference. So for main effects, the null and the alternative are exactly the same as they are in one-way ANOVAs. The null hypothesis is that the means in each condition are exactly the same. The alternative hypothesis is that the means are not the same in each condition. These are the exact same words down here for main effect 1 and main effect 2. They're the exact same hypotheses, the exact same null and alternative hypotheses as you'll see for a one-way ANOVA. And for the null hypothesis, it's basically just the definition of the interaction, but null, that there's nothing. So the null hypothesis of the interaction is that the effect of one independent variable does not change at the levels of the second independent variable. There's nothing going on. There's no difference. There's no effect. The alternative hypothesis for the interaction is that the effect of one independent variable changes at the levels of the second independent variable. That's the definition of interaction. And so interaction is a little tricky. It can be hard to wrap your head around. I've pulled out my two favorite. I don't know if you can hear that. It's my wife talking on the phone in the other room. I've pulled out my two favorite illustrations of what interactions are. I hope they work with you. Interactions can be really hard to think about. As before, if you have any questions, please send me an email. If you have any questions, please go to YouTube. Please go to Google. Again, there's hundreds of people out there who are explaining this stuff. Some of them are going to be good. Some of them are going to be bad. I really tried to do my best so that you can understand it. What I really want you to take away from this two-way ANOVAs lecture is why we would do two-way ANOVAs in the first place. Why we want to do more complex experiments, and what benefit we get from doing two more complex experiments, specifically the benefit of interactions and what those interactions mean. In the lab for two-way ANOVA, I'm going to practice specifically just running only fully between two-way ANOVAs and looking at main effects and looking at interactions and interpreting them. In the meantime, once again, ask me questions. Let me know if something's confusing, and we will talk soon.